Well, the first thing is that most companies who are producing this technology, they're not particularly aware of the local context of the healthcare problems and the socioeconomic landscape that we have to operate under. So I'm Ricardo Guerrero. I recently finished my PhD in bioengineering, and I came back to do some research here in the Philippines. And particularly at the moment, I'm the project leader of the MyPCR project, which aims to make devices to help with COVID diagnostics. So I'm also part of the Bayan Biomedical research group who are trying to develop technologies here in the Philippines to help with primary healthcare access. So developing cheaper and more accessible technologies, we hope to improve the healthcare system, especially at primary care. So the MyPCR is a microfluidic PCR machine. So we're creating tiny microfluidic channels to do all the fluidic handling. And this will allow us to create near point-of-care devices to bring the diagnostics closer to the patients where they need them. So I have over here a microfluidic chip with tiny channels etched into the plastic. So PCR is a very sensitive molecular biology reaction where a single piece of DNA is doubled every single cycle. So if you have a single piece of DNA in solution, after one cycle it becomes 2, then 4, then 8, then 16, then 32, then 2 to the power of n. Typically for COVID, people do this up 2 to the power of 40. So with just a single piece of DNA in solution, you can actually amplify the signal. The issue with that is that the PCR machine typically costs upwards of 4 million pesos per machine. What we're trying to do is we're trying to use scalable technologies which have been convergent over the past decade or so, which has allowed the cost technology to come down. So microfluidics allows us to do that by making these diagnostic cartridges which you can use to send out to the different primary healthcare facilities. And the electronics goods, we hope to make the entire solution maybe under 50,000 pesos as opposed to the 4 million pesos for the commercially available machines. So we're trying to repurpose the technology was created for consumer purposes and consumer goods and use that to bring down the cost of instrumentation required for the device that we're making. So by developing technology here in the Philippines and really tailored towards the Philippine context, this allows us to be more reactive to issues that we have here.